Welcome back from Thanksgiving break. I hope you all had a good week. And if you're not here on Monday or Tuesday, you should be here on Monday and Tuesday. So please try to catch up. In this final lesson, we're going to learn about special situations when you have finite solutions and with no solutions. And we learned the three options that I've been calling graphing, substitution, and elimination. You can actually use either one of them for these problems. So here's our first example in infinite solutions, and obviously it says infinite solutions up here, so we know it's going to have infinite solutions. Now, what does it mean that there are infinite solutions? Well, graphically, let's pretend like this is our graph. Remember, I'm not doing a good job. I'm not labeling my things, but you should always be labeling everything. Oh, this is a y. This is the x. When you have infinite solutions, it pretty much means that you have the same line. So that's line 1, and this is line 2. Now it's not perfect on here, but realistically it means they are the exact same line. And for this example, solve the linear system shown below. Now you can do this either way, and again, usually, I like to label everything. This is equation 1. This is equation 2. You can use any of the three methods, any of the three options that I mentioned before, but for this case, I think I'm going to use the elimination method, and here I'll show you why. This is a tough example, so pay attention. So I'll write that on the first one. Y equals 8. The bottom would be negative 14x plus 35y equals negative 28. Now this is a little more complicated than what we've seen before. However, it's still going to be very similar to what we've done before. So let me draw that arrow. So for the first equation, if I multiply that by positive 7, I will get 28x minus 70y equals 56. Now if you're looking at the notes online that I typed up for you, you'll see there's a mistake on there. So make sure you go back and fix that mistake if you decide to look at the notes. Now at the bottom one, I'm going to multiply by 2. I'm going to get negative 28x plus 70y equals negative 56. This next step in the elimination, you add them. These are going to cancel out. These are going to cancel out, and these are going to cancel out. So you get 0 equals 0. Now, what does that mean? Well, that means that this is always right. This is always correct. So 0 always equals 0, right? So this means that this is the solution. It's always going to be one line on top of the other. Now, if you want to take it a step further and think like a great college student, you actually realize that if you simplify these two equations over here, let me choose a different color. If you simplify those two equations, you will actually get them to be the exact same thing. Now, it doesn't look like it you can't really tell just by looking at it, but if you do the math, you will actually get that. Okay, so here's our last example for this lesson. No solution. Now let's look at what this means graphically. See, this is my graph. This is the y, this is the x. Pretend like it's a really perfect graph. Now what it means for us to have no solutions, it pretty much means that the lines don't intersect. So, remember, two lines that don't intersect are parallel. So let's say this is equation 2, this is equation 1. What this means graphically is that the lines don't intersect. So they will never touch, and in this case the planes will never crash, so there are no solutions. So, for this example, I see an x by itself. I know there's an x by itself, so I actually want to use a substitution method. So let me start off with number 1. X minus 2y equals 4. Let me add 2y to both sides. Here, x equals 2y plus 4. So now that we have this new equation, let me write that in the box. Let's plug that in to number 2. So number 3 is 3x minus 6y equals 8. Remember, we're going to plug the x in, so we're going to get 3 times 2y plus 4 minus 6y equals 8. So you distribute, you're going to get 6y plus 12 minus 6y equals 8. Let me scroll down a little bit more. You combine this 6y and this 6y, you're going to get 0y minus 12 equals, what is that? Negative 4? Or 0 equals negative 4. So now think about this for a little bit. When the 0 equals negative 4, it actually never equals negative 4. So this is how you can tell algebraically you will get two numbers that are not the same. So just to review everything again, when you have infinite solutions, graphically it means that the two lines are going to be on top of each other. Numerically, you can get something like 6 equals 6, or 0 equals 0, or 2 equals 3. Now when you have something that has no solutions, you would have two lines that are parallel. That means that their slopes are the same, so they will never touch. So you get something like 6 equals 0, or negative 4 equals 5, or negative 3.1465 equals 1. These are the same, these are not the same. So now go ahead and start the classwork. I know this is a long video. Classwork is really going to test you more on whether you know how to do it, because or whether you get the idea, because now you know how to do it. Once you finish with that, make sure you finish the discussions and all the other assignments left. And please, please, please make sure you turn everything in on time.